In this problem, we have been asked to solve x to the fourth minus 6x squared minus 8x plus 24 equals to 0. My first thought is to try to factor. If I tried to factor this 4-term polynomial by grouping, I could not factor it. So, in order for me to solve this equation, I need to find roots of this equation, solutions of this equations. So being that I can't factor, to find possible roots and solutions, I will use P's over Q's, my rational zero theorem. P is 24, that's your constant. Q is your leading coefficient, which is 1. What are my factors of 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay? Now, so let's list all the possible factors of 24. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. Divided by factors of Q is plus or minus 1. Now, if you were to divide every P by every Q, we would divide each one of these by 1, getting our final answer to be 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 1, 3, and so forth on. You're dividing each one of these by the Q, which is 1. So these are my possible rational zeros. Now, so to find a solution, we will choose these one at a time, run it through synthetic division, and find a remainder of 0. So let's start testing positive 1. Now, we want to make sure that everything is in descending order and that we're not missing any terms. Looking at my original problem, I have an x to the fourth, but I'm missing an x cubed. So I need to put in 0x cubed minus 6x squared minus 8x plus 24. So this ends up being the polynomial that I will use to pull down the coefficients. There's a 1 in front of x to the fourth. So I will use 1, my x cubed term is 0, negative 6, negative 8, and 24. So let's run it through synthetic division. I am testing positive 1. So let's pull down 1, multiply and add. 1 times 1 is 1, add, we get 1. 1 times 1 is 1, add, we get negative 5. 1 times negative 5 is negative 5, add, we get negative 13. And 1 times negative 13 is negative 13, add, we would get 11. So, you see that 1 is not a solution because we did not get a remainder of 0. So 1 is not a solution or a 0. Okay? So next, let's try negative 1. Running negative 1 through. 1, 0, negative 6, using the same numbers that you did when you tested 1. Now let's test negative 1. Pulling down 1. Negative 1 times 1 is negative 1. Add, we get negative 1. Negative 1 times negative 1 is positive 1. Add, we get negative 5. Negative 1 times negative 5 is positive 5. Add, we get negative 3. Negative 1 times negative 3 is positive 3. Add, we get 27. So again, negative 1 is not a solution. It's not a 0. Okay? So next, let's continue finding other, or testing other numbers. Let's try positive 2. Going to the next number on our list of possible solutions. Using these same numbers again, 1, 0, negative 6, negative 8, and 24. Pulling down 1. Multiply and add. 2 times 1 is 2. Add, we get 2. 2 times 2 is 4. Add, we get negative 2. 2 times negative 2 would be negative 4. add, we get negative 12. 2 times negative 12 is negative 24. Add, you get 0. So it ends up that 2 is a solution. Okay? Now, normally, we would write, thinking of the original problem was x to the 4th. If you lower this down 1, I would get x cubed plus 2x squared minus 2x minus 12. And I would normally set this equal to 0 and try to factor it. Let me show you that we cannot factor this. This is a 4-term polynomial. If I tried to factor, I'd take out x squared. What can I take out of the first 2 terms? You can take out x squared. If you go through and divide each one by x squared, it would leave you x, when you subtract exponents, plus 2. What can you take out of the last 2? Well, out of these last 2, negative 2x minus 12, I can take out negative 2. If you go through and divide each one by negative 2, you would end up with x plus 6. When these two parentheses are not the same, you see that I cannot factor this. All right, pull down 1. 2 times 1 is 2. Add, you get 4. 2 times 4 is 8. Add, you get 6. 2 times 4 is 12. Add, you get 0. So 2 is a solution the second time. 2 was a solution the first time, and now 2 is a solution again. Well, when we found the original problem was x to the 4th. When we found 2 to have a solution the first time, it came down to x cubed. So this one was x cubed. When we ran through 2 again and we found 2 to be a solution or a double root, that lowers it down to x squared plus 4x plus 6 equals to 0. So we will take this trinomial. We will try to factor it to find the remaining 2 zeros or 2 solutions. But if I tried to factor that, there's not any factors of 6. You think about it. Factors of 6 are 1 and 6, 2 and 3. Will either one of these numbers add together to give you 4? No. So we will have to use the quadratic formula again. So let me go to a new sheet of paper and use the quadratic formula on x squared plus 4x plus 6. So using the quadratic formula on x squared plus 4x plus 6 equals to 0, a is 1, b is 4, c is 6. Using the quadratic formula, negative b plus or minus the square root of b squared, 4 squared, minus 4 times a times c, all over 2 times a. So I have negative 4 plus or minus the square root of 4 squared is 16. Now this negative 4ac, multiply all that together. Negative 4 times 1 is negative 4, times 6 is negative 24, divided by 2. So we end up negative 4 plus or minus the square root of negative 8 divided by 2. Recall from your first test, if you have a negative under the radical, you must bring out the square root of negative 1 is I, and 8 staying under. Okay, so that's my first step. So here I have a complex answer, complex root. Can I take the square root of 8? No, but we can break 8 down to 4 times 2. So I end up with negative 4 plus or minus I, the square root of 4 times 2, divided by 2. Okay? This, I broke up 8, and I've brought it here. Now, what's the square root of 4? It comes out as 2. You multiply 2 times the I that's already out there. This 2's under. I still have my negative 4 plus or minus 2I, square root of 2, over 2. Now, you can divide each one of these by 2. That's negative 4 over 2 plus or minus 2I, square root of 2, over 2. Well, negative 4 divided by 2 is negative 2 plus or minus 2 divided by 2. Those cancel, leaving I, square root of 2. Now, remember from your previous work that we found 2 to be a 0 twice. Then we have the remaining 2 solutions. Negative 2 plus I, square root of 2, and negative 2 minus I, square root of 2. So there is your answer to this equation. Remember, I found 2 to be the first solution, and then since I couldn't factor, I tried 2 again. 2 was a 0 the second time. Then I ended up getting this trinomial that I could not factor. So I ran it through. Once you get it down to x squared, you can always run it through the quadratic formula. So I ended up having the square root of a negative underneath here. That gave me the I. And I simplified it on down to these were my final 4 answers to this problem.